Hello, welcome to this C# support video. This is the 8th in the series on cybersecurity, where we're building on, it's very similar to cybersecurity number 7, which was a brute force MD5 hashing insecure password finder. This time it's slightly less insecure, as in it finds slightly less insecure passwords because for two reasons. Number one, it's using SHA-256 rather than MD5, which has a lower chance of collisions, which means that the hash itself is longer, it uses more bits, which means that it's much more likely that you can have two completely different passwords that generate the same MD5 hash. It's much less likely that two completely different passwords will generate the same SHA-256 hash. It's also slightly more secure, not very secure, because we're dealing with letter digits. They're only capital letters though, and there's only 3 of them. If we went for 4 digits, then this code would probably not run. It would probably take too long to run to generate the password that you're allowed to do on this completewithcode.uk setup. But it shows that it's possible to try and find insecure passwords in a fairly short amount of time if the password is not secure. So let's implement our password finder class. Let's make a public method called brute force, which returns a boolean, as in true if we find the password, false if we don't find the password. It accepts one parameter called hash, and we also need an attribute, so that's going to be public string password found. So that is going to be set to an empty string to begin with, but if we manage to find if we find the password from this hash, then we can overwrite that empty string. We should return false if we can't find the password. So hopefully we should get rid of all of the syntax errors, but obviously it doesn't actually find the correct password. Notice that these hashes are longer than MD5 because it uses twice as many bits to generate them. But we should be able to go through every possible combination of characters to work out what the password is, and ultimately find out that it was randomly chosen to HTV here. So how do we do that? Well, it's all sorts of different ways to do this. I'm going to use 3 nested for loops. So let's say for char character 1, the first character, in this case is going to be H, and we'll set that to A. C1 is going to be, notice that for a character we use single quotes in C#. We need it to be less than or equal to a capital Z, because remember a character just uses ASCII encoding. A comes first in the alphabet, Z comes last, and they're all in order. And we can just increase that by 1 each time. Then we want to do the same kind of thing for the next character, for char C2. So what is char? It's just a byte that stores the ASCII code for this particular character. So we'll do the same thing. So why don't we just copy and paste this 3 times and then change it. This is going to be the second character, and then the third character. I'm sure there are more elegant ways of doing this, but I think this is one of the most readable ways of doing this. So we've got a nested loop here. What do I mean by that? I mean any line of code here is going to run for every possible combination of the third character, and then this whole loop is going to run for every possible combination of the second character, and then both of these loops are going to run for every possible combination for the first character. So that means we should be able to try a password that we're working on, and we'll say password is equal to, let's see, we want the first character, and then the second character, and then, third character, which should give us every possible combination. Let's just write it to the log so that we can see if that's going to work. did I call it? Password. Great. I know I haven't generated the hash yet. I just want to see if it goes through every possible combination of passwords. Yeah, here we go, trying AAA, and it should go through every possible combination, which you can see takes quite a long time, even though it's just 3 digits, and even though it's just capital letters. It's a, you know, it's not a simple computational activity. Okay, I'm not going to print that every time. What I do want to do is generate a hash. So let's generate an SHA-256 hash. Oops, SHA-256 hash from that password, and we'll say if that generated hash matches the parameter called hash, then we do 2 things. First of all, we store the password that we found, and then we can return true to break out of all of these nested loops and say that we found the password. If not, we go through all of the loops and we'll eventually return false, and the password found will have been reset back to an empty string. You might say, why do we need this and this? Well, we don't really. We could use one string for both, as long as we reset password found back to an empty string before we return it. That'll be fine. Okay, so now we just need to implement this. I'll do it private this time. So private string generate SHA-256 hash. We need to know what the input is. And it's going to be very similar to what we did in the last one. So SHA-256 hasher, SHA-256.create. This hasher object can compute a hash from some data, but that data needs to be an array of bytes. We only have a string, but we can get an array of bytes from a string if we say how that string is encoded. So let's say encoding.ascii.getBytes, pass in that string as a parameter, and the return value is going to be an array of bytes. We will then get a different array of bytes out as the return value from compute hash, and that's one that we want to store. So let's say byte, an array of bytes called bytes, and then we can iterate through it. For each byte be in our array of bytes, so we can iterate through every byte in our SHA-256 hash. What do we want to do with it? Well, we want to add it onto a string that we can then return. So we'll make an empty string, we'll return that string, but by the time we return, we don't want it to be empty. We want to add on the hex digest of the hash. So remember, hexadecimal is just a concise way of representing binary data, because each byte is 8 bits and each byte is 2 characters in hexadecimal. So we can display that byte in hexadecimal as capital letters using 2 characters. That's important because if the byte is 0, we don't just want to put a 0 as hex, we want to have 0, 0 in hex. Otherwise the hash isn't going to necessarily be the actual length that we're expecting an SHA-256 hash to be. Will it work? Probably not, but let's have a look. Confidence. So notice it does take a significant amount of time to run because it's got to generate all of those hashes. So it's found some of them, but it's taken too long. Maybe I need to simplify the problem so that it doesn't run through all of them. So is there any way that we could optimize this? I think this is probably going to take too long. I guess it depends what the randomly chosen things are as well. It just says time limit exceeded. I mean, we could try. I don't know how long this bit takes, but we could. The thing that's going to take the time is all of this, isn't it? So I think I'm going to have to edit the code so that it only has one test rather than all of them. But you can see how long this computationally takes. What have I just done? Right. I'll only test it with 2 passwords this time and see if that runs in the time limit. Let's see. Yes, excellent. That will do.